So some of the questions that you'll asked to do with some of these transformations is to actually sort of work backwards. Typically, you're given your graph of f of x, and you're told some messy bunch of transformations on f of x, and then you're asked to draw the new transformation. So something else that we can do is actually work backwards. I could give you f of x, I could give you the new graph, and then ask you to find the transformation. So that's what we're doing here. So I phrased it in terms of the function f of x. So my expression should have f in it. Find the equation of the function below. So you should be able to look at this and hopefully see that it's been transformed in kind of clean linear ways. There's no weird twists or anything or shears. It's just stretches, compressions, flips, and shifts. And so what that means is that I should be able to somehow write this as y equals af of bx minus h plus k. And so our goal is essentially to find abhk. So I've written all the coordinates, those main coordinates down on the two graphs, just in case it's not immediately clear where they are. So one of the things you might notice if you try to look for shifts right off the bat, it's not consistent across the board. So for example, this open dot, if you look at the x value, it goes from -4 to -8. So that goes left by 4 for the open dot. This first closed dot, and so what we're looking for are the horizontal and vertical stretches, compressions, or flips. I think the easiest way to do this is to just look at the size of the two graphs. So for the first graph, we start with a width of, if we look at this, it starts at -4 and goes to 1, so that's a net width of 5. And if we look at the one on the right, it's starting at -8 and then going across to +7. And that's a net length or width of 15. And so that is a horizontal stretch of 5. And if we look at the heights are going on the first graph from 1 to 2. So that total height is 1. And on the second graph, it goes from 0 to 2. So that's a total height of 2. And so that's going to be a vertical stretch by 2. I just realized I said that's a horizontal stretch by 5. 5 times 5 is not 15. That is a horizontal stretch by 3, not 5. Sorry about that. And so we should be able to use these now to figure out a little bit of information about A and B. So that vertical stretch by 2 tells us that A is, the magnitude of A is 2. We don't know anything about the sign yet. So that's why I've used the absolute value there, because it could be plus or minus 2. And so what we might want to do now is also look at whether or not this thing has been flipped vertically. You'll see that on the left, the open dot is at the bottom, and then it moves up to the top. And then the flat section starts at the top and flips to the bottom, so it has been vertically reflected. So we have a vertical reflection. That means that it's actually going to be a negative value. So that tells me that A is -2. And on the horizontal one here, so remember this one's affecting the B, so we're actually going to get that it has a magnitude of 1/3. Remember, those things happening to X sort of do the opposite. So the opposite of multiplying by 3 would be dividing. And again, I don't quite know the sign until I look for flips or anything. And now I look at this, I see the open dot stays on the left in both pictures. The flat section stays on the right. So there's no horizontal reflection. So I can conclude that B must be positive. And so that's going to give me my A and B. And since when we graph these things, we should do the A and B first if it's written this way. So this is going to basically sort of give me the first two steps. And if I want to finish this picture to find the H and K, what I'm going to do is apply A and B and see what happens. So to find H and K, what I'm going to do is graph the AF of BX to see what shifts are still needed to get the graph on the right. All right, so I'm going to do that below. All right, so I've just kind of in the background there, I've drawn my XY axis, and I've drawn the original graph y equals f of x in this light blue. And so I'm going to apply those two transformations. So I know that the first one is that going to be this horizontal stretch by 3. Why don't I actually just keep that with the same color I was already using? So that horizontal stretch by 3, my x's are all going to get tripled. And then I will also do, let's say, this vertical stretch by 2, as well as the reflection. So my y's are going to all go to -2y. So I'll do, I guess it doesn't really matter. For the sake of doing things left to right, I guess I'll do the A first and then the B second. Remember, it doesn't matter for those because x's and y's don't mingle. But it also makes sense for me to do green first, just so the final graph is in the richer burgundy color. So yeah, so all my y's are going to go to -2y. So I've got a +1 is going to go down to -2. 2 goes down to -4. And that is also 2, so it will also go down to -4. So I'm going to get those green dots down there. It's hard to tell that that does have a vertical stretch, but I think you can maybe see that that diagonal is a little steeper than it was a minute ago. Try to move that a little bit. All right, it's supposed to be flat. It's not quite flat. That's okay. And then I'll do the burgundy one. So all the x's are going to get tripled. So this -4 is going to now come out to -12. You'll notice I very poorly extended my axis there to make that happen. -2 is going to go to -6, which should be over here. And 1 should go to 3. And so that'll move out over there. I'm just going to label all of these points while I've got them. So this should be -12 and -2. And this point here is at -6 and -4. And this point is at 3 and -4. And I'll just connect my dots. There we go. And so, yeah, so this graph here is going to be the complete A of A times f of bx. And so really all that we have to do at this point is those two shifts. And so what we can do now is just see what is happening to all these points to get to the new points. So my open dot here, if I go from this graph here, is at -12 and -2. And it's got to turn into the open dot at -8 and 2. The middle dot at -6 and -4 is going to turn into the middle dot at -2 and 0. And the rightmost dot at 3 and -4 is going to turn into the 7 and 0. And so those are the numbers off of the graph on the right here, in case you didn't catch that. So this is the finished product graph. And so yeah, we just really need to see what's happening in each of these. What you should notice is that in each case, all of them, x turns into x plus 4, every single one. And the y's are actually also doing that. That's just kind of a fluke. So y is also becoming y plus 4. And that should tell us what we need for the rest of our equation. So what we're going to have to do then is sneak in for the blues. I guess what I'll need is all of these are going to force in a -4 there. Remember, because that should be kind of like opposites. And then on all of the y's, those are going to put a +4 on the outside. So that looks really horrible. I'm going to rewrite the whole thing. But what we should have is y equals, my a was -2, b was a third, and then we get that factored x, and I'll just rewrite this with this blue here, -4. So it does the opposite of what we see there. And then that +4 is going to come from the effect of the y's. So that on the bottom should be the final answer. I think for the most part, you can probably get as far as finding your A and B, but really to get those H and K, you have to see what A and B do. And then with that shifted, compressed, flipped graph, once you see that, then you'll be able to see the shifts. That's how you would approach any of these problems.